Alright, so for this video, we will continue with our examples that want us to find out the rejection region on our own. Right. Okay, so if you have a look for example 43, okay, so when the guitar is played regularly, a string breaks on average once every 15 months. So from here, you can see that it is a Poisson distribution because the interval is given here. Alright, so broken strings occur at random times and independently of each other. So it is fitted with a new type of string which is claimed break less frequently. So the word less actually gives you a hint about the alternative hypothesis. Alright, so the number of broken strings of the new type was noted after a period of 5 years. So instead of 15 months, okay, they observe it for 5 years. Alright, so that means this is a new interval that you are going to use when you want to do any calculation later. Alright. Okay, so the mean number of broken string of the new type in the 5-year period is denoted by lambda. So find the rejection region for the test at 10% significance level when the null hypothesis is 4. Okay, lambda equals to 4. Tested against the alternative hypothesis, lambda smaller than 4. So here they already tell you that the 4 is the lambda for 5 years already. Okay, so they just want you to calculate the rejection region. Alright, so we can start here. For the null hypothesis, alright, okay, lambda is equals to 4. Alternative hypothesis, the lambda is smaller than 4. And I know that it is Poisson distributed with 4 for 5 years. Right, then now again to calculate or to get the rejection region, what I need to do now is I will want to draw a diagram to help me to visualize it. Okay, so this is 0. This is the number of x. X can start from 0 until infinity for Poisson distribution. Alright, then now I want to put in my rejection region. So my rejection region, this is a one-tail test. If you look at the alternative hypothesis, so one-tail test, the rejection region should be on the left because of the smaller sign. Alright, so I will just put like this. Okay, so this area will be my rejection region. And I know that this whole area here, it is 0.10, which is 10%. Okay, the significance level. So similar with what we learned in binomial distribution, you need to start to find out the rejection region from the left. So you should actually start from x smaller equals to 0. But as what I mentioned to you before, the x smaller equals to 0, I know that usually it won't be the answer. Okay, so usually I will skip the 0, I will start with 1. So I will want to start with x smaller equals to 1. And what is the probability here? Okay, so since the lambda is 4, so smaller than 1 means e negative 4, then 1 plus lambda, so 1 plus 4. Alright, so the first answer that I get is 0.0916. Okay, so if I compare it with my significance level, right, 0.10, it is smaller. Right, so I should continue to calculate the next number, which is x smaller equals to 2. So you will see that I didn't skip any number here, 1 then followed by 2. It is because of I realized that the p-value here, the probability already very close to 0.1. So I will not going to skip the value here. I will straight away find out the probability for x smaller equals to 2. Okay, so apply the Poisson formula, and if you press the calculator, you'll get 0.238. And if you compare it with the significance level, it already more than the significance level. Alright, okay, so what does this mean? It means that, okay, you can stop here, right, because you already have more than 10. So you have a look for all this. Okay, so for 0.0916, that means what? That means that when your x is equals to 1, the area for x smaller than 1 or smaller equals to 1, the blue color area here is 0.0916, okay, which is smaller than the area 0.1. And if you have a look for the probability of x smaller equals to 2, you get an area that is larger than 0.1, right? So the area larger than 0.1, it will be this green color part. So since the area is more than 0.1, so that means when you shade the area, it should be more. And then this line here will be the 2. Okay, so if you also observe the diagram here, you will see that 1 is under the rejection region, 2 is already under the acceptance region. The white color part will be acceptance region, right? Alright, then from here very clearly you can see that where is your rejection region. So you can write out your rejection region. Okay, you can write it out as x smaller equals to 1, or you can write as x smaller than 2. For me, preferable, I will still write out like this, x smaller equals to 1. Okay, so this is how we actually get the rejection region from a Poisson distribution. So the method is still the same like binomial, just that the formula that you apply, we are using Poisson. Okay, so if no problem, then maybe we can continue with another example. Okay, so let's have a look for example 44. Okay, so from this question, they already tell you that you have a Poisson distribution, the number of white blood cell count. Then before undergoing the treatment, the patient has a mean white blood cell count of 5.2. All right, so after the treatment, a random measurement of patient's white blood cell count is made and it is used to test the 10% significance level whether the mean white blood cell has decreased. Okay, so I think this word decrease will be the keyword, okay, to help you to form the alternative hypothesis. All right, so first they ask you state what is meant by a type 1 error in the context of the question and find the probability that the test results in a type 1 error. Okay, so they're asking for two things here. First, they want you to explain, all right, the type 1 error in the context of the question. That's the first one. And after that, they want you to calculate the type 1 error, the probability of the type 1 error. All right, so how can we do that? Okay, so let us start. First of all, what I want to do is maybe I want to write out the null and alternative hypothesis first. So for this one, lambda is equals to 5.2. And then for the alternative hypothesis, the lambda is smaller than 5.2. So when they say alternative hypothesis lambda smaller than 5.2 means that the treatment actually decreased the white blood cell count, right? Okay, so how can we write it out in the type 1 error in the context of our question? All right, so you can write it like this. Type 1 error means that you reject the null hypothesis. So when you reject the null hypothesis means that you accept alternative hypothesis, right? Reject null hypothesis means you accept alternative hypothesis. So when you write out the sentence is you actually conclude that. So this is the result. Okay, this is the result that you get when you run a test. So you conclude that the mean white blood cell count has decreased. So this is what you conclude, right? When you reject the null hypothesis, okay? But when the null hypothesis is true, although it is not, okay? So although okay, so when the null hypothesis is true means that although in fact the white blood cell count not decreased, but we conclude that the cell count has decreased in the text. All right, so this is what we have for the type 1 error in the context of the question. Okay, then now they want you to calculate the probability of type 1 error. Okay, so to calculate the probability of type 1 error again, from this question, they didn't give you any rejection region if you read through it. So you need to calculate the rejection region on your own first before you can calculate the type 1 error. Alright, so I will want to get the rejection region first. So X is Poisson distributed and the mean is 5.2. And then I will want to draw a diagram out to help me to understand it easier in an easier way. So my X can be 0 until positive infinity. Okay, so if you look at the alternative hypothesis, it is a one-tailed test on the left. Therefore, I need to draw a rejection region on the left-hand side. And I know that this area is alpha. So in this case, alpha is 10% also, right? So you have 0.10. Okay, then now I want to find out the rejection region. So I will start from the small number. Okay, so how can I do it from the small number here? Okay, again, I will skip 0. So I start from x smaller equals to 1. So when I start x smaller equals to 1, it will be e negative 5.2. Okay, then 1 plus 5.2. Okay, then what is the answer? 0.0342. So, which is still smaller than 0.10. Okay, and after that, you can try to calculate x smaller equals to 2. Alright, so e negative 5.2, then this is what you have, you start by x equals to 2. Okay, when you calculate this one, you get 0.109, and you will see that, you will see that the value itself already more than 0.10, slightly more than, right? So what does it mean? It means that for this value, 0.0342, okay, the area is small. It is still below, okay, inside or within the 0.1 area. So this value itself here will be x equals to 1. Alright, then when you look at 0.109, this area is larger than 0.1, slightly larger. So that means when you draw the area green color, this area should be slightly more than the area for 0.1. So this is the value 2. So again, 0, 1, and 2 here, very obvious, you can see that the 0 and 1 is under the rejection region and the 2 is at the acceptance region. Okay, therefore, your rejection region will be x smaller equals to 1. Okay, alright, so you already decide your rejection region now. Okay, then you want to proceed with the calculation of type 1 error. Alright, so what can we do now? Okay, so to calculate the probability of type 1 error, the definition is you reject the null hypothesis when the null hypothesis is true. Okay, so what you want to put in now is you put in the rejection region x smaller equals to 1 when the lambda is equals to 5.2. Okay, so if you apply the formula, okay, so you get 0.0342 as your answer for type 1 error. Okay, but if you realize this answer is actually appeared just now already. Okay, when you try to find out the rejection region. So you can see x smaller equals to 1, x smaller equals to 1 when the lambda is equals to 5.2. These two, although the symbol looks different, but actually they are having the same steps. Alright, so your final answer should be the same also, which is 0.042 or 0.0342. Okay, but in short, you still need to find the rejection region before you can calculate the type 1 error. Okay, so this is what you have for part number 1. So you already get the rejection region from here. in first part. Okay, then you can use this rejection region, continue with other calculation later. Right, so you have a look for part number 2. Okay, so given that the measured value of the white blood cell count after treatment is 2, then they want you to carry out the test. Okay, so in first part, you already get the rejection region, right? You know that x is smaller equals to 1. So that means when x is equals to 0 or x equals to 1, you reject the null hypothesis. Okay, for this question, they said the blood cell count after the treatment is 2. That means x is equals to 2 lah. Okay, so now you look at the 2 here. Is this value 2 falls under the acceptance region or rejection region? Okay, so you can make a very short test like this. Okay, so rejection region is x smaller equals to 1. Then since x equals to 2 falls out of the rejection region, therefore what we do is we fall out the rejection region, right? So that means you accept the null hypothesis, or you can write you do not reject accept the null hypothesis. Yeah, so you do not reject the null hypothesis. Okay, so which means what is the conclusion? If you didn't reject the null hypothesis, means that is the white blood cell count decrease or not? The white blood cell count does not decrease. The new treatment, okay, does not decrease the white blood cell count, something like this. Okay, because you accept the null hypothesis, right? Okay, therefore, the new treatment does not decrease the white blood cell count. If let's say when you're having x equals to 2. Alright, okay, so this is how we do. So you will see that in this part, we are not running a full test. If you want to run a full test, still okay. Just that for some students, right, who can see that the rejection region is x smaller equals to 1 and x equals to 2 falls under the acceptance region, you can use this concept, right, to run the test if you want. Okay, alright, so this is another option for you. But if let's say you feel that this one very hard for you to understand, or you feel like you don't like this method, then you can still follow the full method that I teach you before for Poisson test, right? Okay, then continue further. For the third part, they want you to find the probability of a type 2 error, okay, when the mean becomes 4.1. Okay, so this one can be quite straightforward already. Alright, so to calculate the type 2 error, the definition is accept the null hypothesis when the null hypothesis is false. You accept something false, so you make an error. Right, so when you accept the null hypothesis, what is it? What is the acceptance region? So x smaller equals to 1 is the rejection region. Therefore, x greater than 1 will be the acceptance region, the opposite sign. Alright, then now hypothesis is false, that means you should have a new lambda. So the new lambda here will be 4.1 given in the question. Okay, then you remind yourself x is Poisson distributed and the lambda is equals to 4.1. Okay, then you calculate the probability. So x greater than 1 means that you actually want to minus. So 1 minus e negative lambda. Then x equals to 0 is 1, x equals to 1 is lambda. Okay, then from here you get 0.915. Okay, so this is what we have for type 2 error. Okay, so For this example, in part 1, although they didn't ask you to find the rejection region, but you need to find out on your own so that you can calculate the type 1 error. Then use the result to calculate the type 2 error in this part. Alright, okay, so this is the examples that involve the finding the rejection region on your own. Okay, so similar thing happened for example 45. Okay, so maybe for example 45, I will want you to try it on your own. Okay, I will want you to try out on your own, and then I will give you some final answer here. But of course, I will still discuss a little bit with you so that you know how to do it. All right. Okay, so we discuss example 45 together. Okay, so in the past, the number of house sales completed per week by building company has been modeled by a random variable which has distribution Poisson 0.8. Okay, so this is for per week one, the number of house sales. So following a publicity campaign, the builders hope that the mean number of sales per week will increase. So the word increase gives you a hint about the alternative hypothesis. Okay, in order to test at the 5% significance level, whether this is the case, the total number of sales during the first 3 weeks. Okay, so you need to aware the 0.8 is for 1 week one per week, and later when you do any calculation, you need to focus on 3 weeks interval. After the campaign is noted, it is assumed that Poisson model is still appropriate. Okay, so first, given that the total number of sales during the 3 weeks is 5, carry out the test. So now they want you to carry out the test, and they give you number 5. Okay, so which means that you should actually know the 5 here is the observed value for you to run the test on. I hope that you still remember all these, alright? Observed value. So how can we start? So first step, of course, you need to write out the null and alternative hypothesis. Okay, for this part, actually you can try to pause the video first. Then you come back. Okay, for the first part, you can do it on your own. Alright, so the lambda should be 2.4 for 3 weeks. I straight away change it become the 3 weeks mean. Then increase, right? So more than 2.4. Okay, so this is my first step. Write out the null and alternative hypothesis, and then I will just write a sentence about the alternative hypothesis. So the mean number of sales per week will increase. Alright, then I know that for this part, it is Poisson distributed. So it is Poisson distributed. The lambda is 2.4. Okay, then I want to calculate the observed value x, and then observed value is 5. So should I put greater equal or smaller equal? Okay, then again, according to the alternative value here, the sign here is greater, right? So your calculation should be more than or equals to 5. Okay, so you apply the formula for Poisson, 1 minus e negative lambda, and then you are having 1 plus lambda, okay, plus lambda square over 2 factorial, okay, then until 4. Because greater equals to 5 means start from 5 until infinity, right? So when you minus until 4 only. So your p-value should be 0.0959. Okay, then now, before I make any decision or conclusion, I will want to draw a diagram. Okay, so this diagram, x start from 0 until infinity. So when they are asking for x greater equal to 5, before that, I want to put in my rejection region first. So this is a one-tailed test on the right. Therefore, my rejection region will be on the right hand side. Okay, and this area itself should be 0.05. 5%, right? So 0.05. Okay, then now I want to put in my my p-value into the graph. So 0.0959. This area is greater than 0.05. So I'm having a great area, blue color area should be more than the red one, the shaded area. And this borderline here is the 5. That means the area for x more than or equals to 5, it is 0.0959. So if you look at this 5 here, generally you know that it falls under the acceptance region. So acceptance region means you do not reject the null hypothesis. Okay, so what is your conclusion here? So your conclusion here will be the mean number of sales does not increase. Okay, so this is what we have lah. All right, for the first part. Okay, you carry out the test by using Poisson distribution, and you learned this before already. So I hope that you still remember the process. Okay, then now let us continue to second part. Okay, during the following 3 weeks, okay, the same test is carried out again using the same significance level. Find the probability of a type 1 error. Okay, so now they actually want you to find out the type 1 error already. Okay, so to find the type 1 error, according to the definition, you need the rejection region. But now they didn't give you any rejection region. So you have to find the rejection region on your own first. Okay, so to find the rejection region, when your test is on the right hand side, especially for Poisson, right? You need to be very, very careful because for Poisson, it starts from infinity. That means the value can go until infinity. So sometimes you have to use some information from the test that you run just now, okay, to try to decide the try and error value that you want to use. Okay, so like this, you know that your rejection region is on the right, correct or not? Okay, so 5 is under the acceptance region. So the next value that you want to test is 6. So you want to know whether the 6 should be here or the 6 should be here. So you have to find out the area for 6 first. So I will start from x greater equals to 6. Alright, so this is how I decide. I look at this value. I already have the area for 5, x greater equals to 5. So the next value I use will be x greater equals to 6. Okay, because usually students will ask me how I know I should start from 6. Can I start from 7, 8 or what? No, because from this part you know that 5 is here. So you should try the next value, which is the 6. So this is how I decide it. Okay, the 6 from the previous graph here. Right? Okay, so again, you try to find out the probability for x greater equals to 6. And then if you didn't do any careless mistake, right? Okay, so I lazy already. I put dot, 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 dot. And then 2.4 power 5 divided by 5 factorial. Okay, then the answer that I get is 0.0357. Okay, so 0.0357, this value already, what should I say? It is actually smaller, right? Smaller than 0.05. And just now one is more than 0.05 for the 5. Okay, so what does it mean then? That means in this part, this p-value here, if we want to put it inside the diagram that we have just now, you can see that the green color area should be a smaller area than 0.05. So which means that the 6 is here already. Okay, so if you look at this diagram, from 0 until 5, from 0 to 5, they falls under the acceptance region, and from 6 onwards, 6 until infinity, it is under the rejection region. Okay, so from here you can make a conclusion that the rejection region should be x greater equals to 6. Alright, so this question is a bit tricky because you actually need to use some information from the previous part, okay, to know which is the value that you want to test. Okay, so for this one, we are doing the try and error method, x greater equals to 6. So the 6, I decide from here, from the graph, right? Okay, then after I get the rejection region, then I can continue with my type 1 error calculation. Alright, so to calculate the probability for type 1 error, it should be reject the null hypothesis when null hypothesis is true. Okay, so what is the rejection region here? X greater equals to 6, given that the lambda is still equals to 2.4, right? Okay, then according to what I mentioned just now or the previous example, you know that the type 1 error is actually this one, which is 0.0357. Alright, so this is what we have for our part 2. Okay, then next one, part 3. So again, they want you to explain what is meant by type 1 error in this context. So you can still tell them type 1 error means reject the null hypothesis. So what is the conclusion when you reject the null hypothesis? We conclude that okay, the mean number okay, has increased, although it is not. So we are making a wrong decision. In fact, it is not increasing, but we conclude that the mean number increased. So that is what we meant by the type 1 error in the context here. Okay, so state what is the further information will be required in order to find the probability of the type 2 error. So I think I told you a lot of times already, right? When you want to calculate the type 2 error, the question will give you extra new information, which is the value of P or the value of lambda in our case. Alright, okay, so this video, we already covered 3 examples that involve the calculation for rejection region. Alright, so especially for this question 25, the example 45, to find out the rejection region, you need to be more alert because you might need to use the previous diagram, okay, to help you to decide the number that you can start to find, whether is it belongs to rejection or acceptance region. Okay, alright, so I'll stop here for this. Then in the next video, I think the next video will be our very last video already for this chapter also. Okay, when we are having the large mean in Poisson distribution, we are going to change it become normal, right? So how are we going to carry out the calculation for errors and also the rejection region in the normal distribution?